Back to the QST YouTube channel. Today I'll be recording the Term 2 Week 5 Math CA quiz. A ball is dropped and bounces such that the height of each bounce is 50% the height of the previous bounce. The first bounce of the ball reaches a height of 10 feet. Fill in the blanks of the correct number. So as we can see here, since it's 50% the height of the previous bounce, that means it's geometric. خلاص, simply. So, and 50% would be the common ratio that we're multiplying each bounce by. The rule for a geometric, like any term of a geometric sequence, is the first term multiplied by g, which I'll call the common ratio, to the power of n minus 1. Here in this case they want 10, so a10 is 10 times 0.5 to the power of 9, which will give us 5 over 256. Yeah. The total vertical distance traveled by the ball from when it first hits the ground until it hits the end of the 10th bounce. Wait. Okay, so for this question, the ball travels twice after each bounce. So let's say here before it hits the ground it's 10, right? And then here after it, they want the total vertical distance. Now I'm gonna show you something which will come in importance later. So first, right, the ball drops down 10, then it bounces off the floor and becomes 5 here, and then it drops to the floor again, 5, then it becomes 2.5. What's important here is that it stays, like it goes up a distance, then it goes down the same distance, which will come in handy. So now, since they want the total vertical distance, we will do the sum of a geometric sequence, which is a1 times 1 minus r to the n over 1 minus r. So we're gonna do 10 into 1 minus 0.5 to the 10 over 1 minus 0.5, which is 0.5. You are going to get 5115 over 226. 5115 over 256. But now, since the ball like goes up a certain height, then it goes down, which means it like drops at that height twice, we're gonna multiply this by 2 to get 5115 over 128. No matter how many times the ball bounces, the vertical distance traveled by the ball is the maximum total distance, the total vertical distance will never be greater than. Okay, so here when they say it will not be greater than, we're just gonna do the sum to infinity. The sum to infinity, so just sum to infinity is equal to a1 over 1 minus r, simply. So 10 over 1 minus 0.5, which is 0.5, you'll get 20. But once again, same reason as the last question, we're gonna have to multiply this by 2, because if the ball goes up, it's gonna go down the same distance to touch the floor. So we're gonna multiply this by 2 to get 40 feet. Number 2. Consider the sequence -3, -1, 3, 5. So first, let's find what's it called? The common difference. So we're gonna do -1 minus -3, which is equal to 2, right? So now what we're gonna do to find the sum, there is a really convenient rule. So the sum of an arithmetic, right? Since they said, since we're not multiplying, we're adding. So the sum is always going to be n over 2, n being the number of like terms. A1 is the first term, plus again n is the number of terms, n minus 1, times d, which is the common difference. So here 2 over 2 is 1. Wait, sorry 12, we're gonna start, I thought 2 was n, which it's not. They said the sum of the first 12 terms, so 12 over 2 into -3 plus n minus, oh, it's 2a1, sorry, I completely forgot about that. It's 2 times a1, so you're gonna get -6 plus 2 times 12, which is 24, minus 2. After you distribute, 24 minus 2, you are going to get 96. Now for the last part, the sum of the first n terms is given by, look, here when they say summation, right, that means the sum of something. The sum of the first n terms, which means the sum of the terms. So they would just want us to find the rule, like here, or we just want to find the rule of the terms. Simply, what we're gonna do, any term in the arithmetic sequence is a1 first term plus number of terms n minus 1 times d. And then we're just gonna substitute -3 plus n, which in this case is I minus 1 times 2. And then we're going to simplify. -3 plus 2i minus 2. You're going to get 2i minus 5. Number 3. Consider the sequence un defined by un is equal to n squared minus n minus 6. What you're gonna do for the first one is substitute n by 1. So 1 minus 1 minus 6 is -6. Then you're gonna substitute n by 2. So 4 minus 2 minus 6 is -4. And then you're gonna substitute n by 9. So 81 minus 9 minus 6, which is 66. And then now they want what term will give us 36. So 36 is equal to n squared minus n minus 6. So what I would do is we would take the 36 to the other side. We would get n squared minus n minus 42 is equal to 0. Now we have a simple quadratic equation which we can plug into the calculator. So x squared minus x minus 42 is equal to 0. N cannot be 0, so you're gonna get 7 and -6. You can cross out -6 because n can never be negative. So we're gonna choose 7. Number 4. Consider the geometric progression 3, 15, 75. Okay, so now there is another rule for this, for geometric sequence, any term in the geometric sequence is g1 times r to the power of n minus 1, right? So g1 in this case is 3. To get r, what we're gonna do is 15 divided by 3, right? So that would give us 5 to the power of n minus 1. Then you equate it to 4, 6, 8, 7, 5, right? Plug this into the calculator. 3 times 5 to the power of x minus 1 is equal to 4, 6, 8, 7, 5. You'll get 7, which is a good thing. We got the answer right. The sum of the first 8 terms. So now you're gonna do the rule. The sum of a geometric term or geometric progression is g1 times, again, 1 minus r to the power of n over 1 minus r. Simple as that. You're gonna plug this into the calculator. So 3 into 1 minus 5 to the power of 8 over 1 minus 5. You're gonna get 292968, which is the correct answer. Number 5. Consider the sequence un defined by -4 un minus 1. So what we're just gonna do here is we're gonna substitute. So we want u2, right? We're just gonna substitute the term before by un minus 1. So -4 into 2 give us -8. So, and then we're gonna do it again. -4 into -8, 32. -4 into 32, we're gonna get -128. Then -4 into -128 will get us 512. As you can see here, this is actually becoming into a geometric progression, right? I hope you guys can tell the pattern since we're multiplying by -4 in each time. So what we can decide is that the sequence un is just a geometric sequence. What did we say the rule of a geometric sequence was? u1 times r to the power of n minus 1. R in this case is the thing we're multiplying by constantly, which is -4. So we're just gonna -4 here, and simply that's what we got. On to question number 6. What is the common ratio of a geometric progression in which the second term is 6 and the fifth term is -162? Now, for this question, there is a simple way to solve it, if I'm not mistaken. We could just simply say, make a system of equations, right? Since let's say a2, which is what we have here, which is 6. Since it's geometric, we're going to do the same thing. a1 times r to the power of 2 minus 1, which is just r. That's it. And then -162 is equal to a1 times r to the power of 4 minus 1, which is r cubed. Now, what we can do here, right? Oh wait, no, my bad. They gave the fifth term, so r to the power of 5 minus 1, which is r to the 4, right? So now what we can do here to get r, which is what we're looking for, we can simply divide both sides, right? So we're gonna do down over up. So negative 162 over 6. A1 and A1 will cancel. We'll have r to the 4 over r, which is just r cubed. From this, we are going to get negative 27 is equal to r cubed. R is simply negative 3. Boom. Number 7. What is the sum of the first 20 terms of the arithmetic progression negative 9, negative 4, 1, 6? Again, the sum of the first n terms in an arithmetic progression is equal to n over 2 times 2a1 plus n minus 1 times d. D, how do we find it? We're gonna do negative 4 minus 9 minus negative 9, my bad. That will give us 5, right? So we're gonna substitute n by 20, right? So as they said, the first 20 terms, and a1 is negative 9. Plug this into the calculator. You are going to get 770. Number 8. The third term of an arithmetic progression is 12, and the 10th term of this arithmetic progression is 33. So now we're gonna do similar to what we did in a previous question. We're gonna find r, which in this case is d, right? So we want to find d. So 12, which is a3, is equal to a1 plus n minus 1, n is 3, so 2d, right? And then the 10th term is 33. 33 is equal to, again, a1 plus n minus 1, n minus 1, 10 minus 1 is 9, so a1 plus 9d. What we can do here, since this is arithmetic, we can subtract everything, right? So again, we're gonna do down minus up and cancel a1, cancel a1. 7d is equal to 21. D is 3. Perfect. So now they want the 35th term. So what we're gonna do is the an rule. a1 plus n minus 1 times d. D is 3, right? a1, how can we find it? a1, since we have a3, we're just gonna subtract d twice, right? So a1 will be 12 minus 6, which is 6, and n is 35. They said, what is the 35th term? So you plug this into the calculator and we get 108. Number 9. The first term of an arithmetic progression is negative 4, and the 14th term is 61. So once again, we're gonna do what we did in the previous question. So negative 4 is equal to a1 plus the oh wait, they already gave you the first term. Okay, plus n minus 1, n is 1, just 4 is a1. So now we could just negative 4 plus, right, They said the 14th term is 61. So 61 is equal to a1, which is negative 4. They literally said it. Plus n minus 1. N is 14, so plus 13d. You're gonna get that d is equal to 5. Done. And then they want the sum of the first 20 terms. So 20 over 2 into 2a1. a1 is negative 4 plus n minus 1, which is 19d. d is 5 as we found in part A, and that is going to give us 870. Number 10. The sum of the first 5 terms in the geometric progression is, okay, again, just simply do the rule. g1 into 1 minus r to the n over 1 minus r. As you can see, r is negative 2 over 4. R is negative 1 over 2. Right? So then we're just going to plug this into the calculator. So 4 into 1 minus negative half to the power of first 5 terms, so n is 5, over 1 minus negative 1 over 2, which is going to give us 11 over 4. Number 11. The 32nd term of an arithmetic progression is 301. The common difference is 9. Okay, this is simple, just a direct application of the rule. 301 is equal to a1 plus n minus 1. N is 32, so 31 times 9. You're gonna get that a1 is 22. On to the next question, number 12. The first term of a geometric progression is 2. The product of the first 3 terms is 64,000. What is the common ratio? Look, so first the common ratio is 2, right? And then the next one is gonna be 2 times the ratio, right? So 2r. And then the one after is going to be 2r times r, which is going to be 2r squared. This all is going to give us 8r cubed is equal to, as we agreed, the product of the first 3 terms is 64,000. So this entire thing is 64,000. So 8r cubed is 64,000. R is 20. Consider the series 1 plus 8 plus 27 plus 64. Look, I don't know if you can tell the pattern, but it's really, really secretive. Here they just did 1 cubed, 8 is 2 cubed, 27 is 3 cubed, 64 is 4 cubed, right? S5, so they want the sum of the first 5 terms. So the next term will be 5 cubed. So what we're gonna do is 1 cubed plus 2 cubed plus 3 cubed plus 4 cubed plus 5 cubed, which is 225. Fill in the blank to describe the rule for the partial sum Sn. Again, I realized it, so that's the answer. What is the value of S40 minus S39? Now look at this. Normally what I thought before recording the video is that we're just going to do 40 cubed minus 39 cubed, which is not the case here. Since they said S, they mentioned S, which is the sum, we're going to do the summation. X is 1 from 1 to 40. You're going to put x cubed like we found in part B, right? And then you're going to do that minus, let me just write it here, from 1, x is 1 to 40, x cubed, right? Then minus, do the same thing again, x cubed, x is equal to 1, you put 39 here. So once we do that, we're gonna get 64,000, which is the right answer. Consider the sequence un, which is defined by recursively for n minus 1 plus n minus 2 with u1 is equal to 2 and u2 is equal to 5. Now let's just u1 is equal to 2, u2 is equal to 5, u3 is equal to, we're gonna find that, u4 is equal to. Now since we want to find u3, un minus 1, this would be u2, right? So we're gonna do 4 times 5 plus 2, that's just gonna get us 22. Amazing. Now we're gonna do the same thing. So 4 into n minus 1, when we want to find u4, we're gonna take u3. So 4 times 22 plus 5 is going to give us 93. 15. 20,000 is invested in a bank at the start. This is, let's say, compound interest is equal to the initial value I plus, not plus, multiplied by 1 plus interest rate, so I'll just write it as percentage. This entire brackets to the power of number of years, y. So what we're gonna do is 20,000 into 1 plus 5%, which is 0.05, all of that to the power of 4, you're going to get 24310.125. Just run to the nearest unit, you're gonna get 24310. Number 16. AN is an arithmetic progression in which a to the 24 minus a to the 8 is 176. So again, we're gonna just a1 plus n minus 1 is 23. We're trying to find the a24 now, d. And then for a8, a1 plus 7d. If we subtract these two, it's going to give us 176. So we cancel this, 23d minus 7d is 16d is equal to 176. So 176 divided by 16 is 11, which is the right answer. Number 17. The sum of three consecutive terms of an arithmetic progression is 24, and their product is 312. What value is the largest of these terms? Look, for this one, I have a really smart way to go for it. Let's say we have three terms, n minus d, n plus d, n, right, since we're adding d each time, n and n plus d. So what we are going to do in this case is what we're going to do in this case is finding n in this case. So n minus d plus n minus d is equal to 24, right? So it's n plus d here. So d and d cancel. You can get 3n is equal to 24. N is 8. Simple as that. And then we're going to use the product to find d. So 8 minus d times 8 times 8 plus d. Now 8 minus d, 8 plus d is 64 minus d squared, right? By the way, all of this is equal to 312. So let's say we divide by 8 on both sides, right? We're going to get 64 minus d squared is equal to 39. We're going to get d is equal to 5. And then they want the largest term, so we substitute d here. We're going to get 13. Move on to question number 18. Rania receives each week 35% in allowance. She used 30% of her allowance to buy snack bags for her pet. Each bag costs $1.5. How many snack bags did she buy? So look, first of all, we're gonna need to find out how much money did she spend to buy the bags, right? So we're gonna do 35 times 30%, which is 0.3, which is 10.5. Then to find out how many snack bags she bought, we're going to do 10.5 divided by 1.5, which is going to give us 7 bags. Number 19, which is really similar to this question actually, but much more complicated. Molina bought 5 bags of garden soil that were all at the same price. The bags were discounted by 40% of the original price. And the discount, she used a $10 coupon that she applied towards the entire purchase. She ended up paying $32. So look, we need to find the total cost before the coupon, right? So what we're gonna do is 32 plus 10 is equal to 42. So this is how much she paid before the coupon. Since they want the original price, we're gonna need to get rid of all of these bonuses, as you can see, to make it cheaper. So we're gonna need to now find the discounted price per bag. She bought 5 bags, so we're gonna do 42 over 5, which is equal to 8.4. But now we need to find the original price, right? So what we're going to do is 88.4, my bad, is equal to 60% because they said there was a 40% of the original price. So the discount is, wait, yeah, my bad. So it was 60% of the original price, right? Since, so 8.4 times, my bad. 8.4 is equal to the price of the, like the price that was kept, right, times what we're trying to find, which I'll call x. You're going to do 8.4 over 0.6, which is 14. Number 20. What is the sum to infinity of a geometric series if its first term is 48 and its second term is 36? Let's recall the sum to infinity rule first, which is g1 over 1 minus r. It's that simple. But we need to find r. So what we're gonna do is 36 second term over first term, which is 36 over 48, which is 3 over 4, or 0.75. So what we're going to do is g1, which is 48, over 1 minus r. 1 minus 0.75 is 0.25, which is going to give us 192. Number 21. The first term of a geometric progression is 48 and the second term is 36. This is basically the same exact question, but with an extra like part. Just do the same thing. I don't think I need to explain this. For part A, just do 36 over 48 to get the common ratio. And then for part B, just apply the sum to infinity rule, which is 48 over 1 minus r, which is 3 over 4 because of what we found in part A, which is going to give us 192. Number 22, our last and final question for today's video. Given that S, U, and V in this order are three consecutive terms of an arithmetic sequence, given and that U is equal to 4V, right? In an arithmetic sequence, the middle, right, which is U in this case, is equal to the sum of these two divided by 2. So U is equal to S plus V over 2. So 4V is equal to, or actually I'm just going to cross multiply 8V is equal to S plus V. 7V is equal to S. They want V in terms of S, so S is equal, wait, my bad. V is equal to 1 over 7S. And then we're gonna do the same thing all over again, right? So U is equal to S plus V over 2. We found what V is, so S plus 1 over 7 S over 2. So wait, U is equal to 8 over 7 over 2 S. Since 2 is in the denominator, we're going to take it up and multiply 8 over 7 by 2. Wait, never mind. You're going to multiply 8 over 7 by 1 over 2. So we're dividing 8 over 7 by 2, just 4 over 7. Yes, simply. That's all you need to do. Anyways, guys, thank you so much for watching this video. I wish you guys the best of luck in all of your future exams, and goodbye.